बोल बोल मॅडम बोला.
Good morning to all the respected participants, esteemed speakers, and our faculty members. A very warm welcome to day two of our faculty development program on modern technology used in electrical power system. We hope you had a great experience yesterday and are excited about the learning and discussions today. So, without further ado, let us begin with the first session of day two. We are honored to have Mr. Navnath D. Thube sir, who will lead us through today's session on modernization in electrical power sector. Since August 2021 to till date, Mr. Navnath Thube sir is Deputy Executive Engineer at MSCPCL in charge of 132 kV Takri means Dwarka Nasik substation powerhouse, where he leads various tasks in operation, diagnostic, and maintenance of substation. Also, power system balancing and day-to-day activities at powerhouse. From March 2015 to August 2021, he was Deputy Executive Engineer at MSCPCL and promoted to EHV, that is Extra High Voltage Project Testing Nasik, as a testing engineer for supervision of new EHV projects testing works before commission into service under Nasik and Ahmednagar district. From October 2010 to March 2015, he was assistant engineer at MSc TCL Nasik in zonal office for electrical technical folios like tender, estimate, and its scrutiny. Also, he led operation and maintenance of 220 kV substation Ahmednagar. Apart from MSc TCL, he also worked with Mahindra Composite Limited in business development and Schneider Electric India Private Limited in project management. Talking about Thubesa's education, he has completed BE Electrical and MBA in Operational Research. He has acquired various trainings on different interesting topics at Yashoda, Siemens R&D and Technology Center, GE Transmission and Distribution India Limited, PGCIL, and National Power Training Institute. Also, Sir attended Train the Trainers Summit and at Cursor and O&M Summit at Bhinder, Mumbai. Last but not the least, I would like to mention about Kubesa's good communication and leadership skills. He always collaborating with colleagues, superiors, and staff to support them, creating learning environment, giving them new ideas, and he is always focused on achievements of organization goals. Now, I request Mr. Navna Tube sir to please start the session. Over to you, sir.
त्यांना सांगा शेअर करा स्क्रीन.
Sir, please share the screen.
Thank you, ma'am. आवाज येतो सगळ्यांना?
Yes, sir.
Good morning, all.
येस सर.
Yes.
येस सर.
Good morning to all.
गुड मॉर्निंग.
Good morning, sir.
Good morning.
Yes. Yes. Good morning to all. Yesterday first lecture, the expert lecture, he told about the grid occurrence, two grid occurrence. Okay. You know, na?
येस सर.
Yes, sir.
On that, I just feel to share last week grid occurrence. Okay.
मित्र आहे माझा. मित्र. नाही मुला शाळेच्या तेच असतं सगळं. स्विफ्ट गाडी आहे रोज. मला सांग मग. माहीत असते. अरे सब आपने साला माझं फक्त ब्रांच बदलली.
My screen is visible to all.
Yes, sir.
Okay. In last week, on date 12 March at 14:50 hours. Hello, येतोय सगळ्यांना आवाज?
येतोय सर.
Okay, fine. South grid collapse due to heavy tripping on 400 kV lines. And for the same, Grid Control of India generate the flash report of South grid occurrence. I just show the same. Okay, please go through the same. Substation, name of the substation: 400 Janur, Kawas, Haldawar, Ichelpore, Sujan, Hajira, Dijen, Kosamba, Ukai, and Akrapar, and 220 kV API. These all substation affected due to this occurrence. And we also faced the same incident in last week. You also get the hamper about that. During this incident, our voltage get suddenly dropped in Nasik, Mumbai, and Pune region because of the total load flow from Nasik area and Mumbai region goes to South Gujarat. Okay, and due to this line, Gujarat generation also affected. Loss of the generation as below: 200 CAPS unit 3 and unit 34, 1264 MW affected Ukai generation 3 and 4, and also then CAPS stage 1 to all unit get affected due to this the tripping of the line. The reason behind the tripping is mentioned by the Grid India is that 400 kV, 400 kV Devgaon Janur DC line tripped at Janur end on B phase to earth fault. Also, Janur GPEC tripped on the 3-phase fault, and during that tripping, other alternate lines, 400 kV API Sugan line is in plan outage. Also, Kosamba Chari line is also plan outage. Kosamba Pansam line is on force outage due to the emergency condition. Also, 220 kV Kawas Haldwara line is on emergency outage. Due to that, what happened? After tipping of this above two line, Jugam and Janur, the all load get collapsed, and generation unit also tripped on the same instant. And due to that, the load demand suddenly increased to South Gujarat. And as you all know, the electricity always flow to load side, and due to this, all generation in Nasik as well as Chandrapur through Bableshwar to Padga and Mumbai region all suddenly flow to Gujarat side, and due to that we face the low voltage issue in Nasik. Okay, you also feel that in last week, and due to that what happened, our voltage get suddenly from 132 kV level suddenly dropped to 77 or 66 kV. During that, we all maintain our system by shutting the all load, 33 kV load shut down. And after that, as per our SLDC instruction, all our Eclara 3 numbers of ICT get charged, and one by one, all system get restored within the 30 minutes in Nasik as well as Mumbai and Pune area also. And on the same, the Grid Control of India Western Reserve Load Dispatch Center generated this flash report, just for your information. If anyone have doubt, can ask. WRDC display all the before and after data along with the tripping details load shedding measures and all that. All the SCADA and relay generated information. Okay, now we get to our main topic, modernization in electrical power sector. My slide is visible to all?
Yes, sir.
Okay.
Yes, sir.
This is actually the presentation on 220 by 130 by 33 kV Kekat Nimbora digital substation. One of the first digital substation in MSTCL in Jalgaon district. The date of commission of substation is 19 June 2019. Are you aware about the digital substations? Anyone? I think my presentation required both side communication. Those who are aware about the digital substation, they can talk. Okay, let's first we explain all the things and afterwards you can raise the questions. Okay. Normally, our conventional substation include EHV switchyard having the various EHV type substation, EHV types equipment like CTPT, breaker, then transformer, and all the cabling work, cable trains, cabling work. Each equipment having their separate individual marshalling boxes, and from marshalling box to our cable work goes to control room. In control room, various panels, control relay panels equipped with relay and data meters. And after that, our CTPT CTPT means EHV substation equipment CTPT measure our day-to-day hourly basis readings, and that transfer to our control relay panel through regular copper cables in conventional substation through MB and that cables, and report to the SCADA as well as all that relay and meters. Now in digital substation, what happens? All this cable work from switchyard MB to control room is replaced by single cable, single optical fiber cable. Digital substation. Substation EHV equipment, then there is a one processing unit which convert our analog data into digital, and that through fiber optic the same data can get our control room through a single cable instead of lot of bunch cable and all this avoid the total our copper cabling work. This is their block diagram. Utility center means control room. There are our EHV equipment, power transformer, and through a single, this is conventional all instrument. From conventional instrument to this MB, we take only use the cable, copper cable. After that, we generate the digital bus, fiber optic bus, and from that fiber optic bus, we get all the data to our control room.
Sir, sorry to interrupt you, but we cannot able to see the block diagram. Actually, first slide is there on the screen.
Can you now visible?
Not, not
No.
itself.
बरं मग बाकी
Okay. Now visible to all?
Yes, sir.
Okay, block
Yes,
diagram.
sir. Yes, sir.
Utility communication is our control room. Conventional, it is called as a conventional control room. Okay. Ah. All issues switchboard, all conventional equipment is there in digital substation. Only the communication cables from equipment or equipment MB to control room is replaced by fiber optic cable. This is all conventional unit, and this one is conversion in our simple language, which convert the all analog signal to digital, and through our digital bus the same can be transferred to our utility communication center, all conventional control room through a digital bus system. This all based on IEC 61850 protocol. Digital substation with process bus. These all are the switched equipment. After that, we get on this process bus, and through process bus, the same data can transfer to our control room, that is utility center, through digital bus using IC 61850 protocol. All signal digital on station and process level. All information available on communication network along with measures and switchgear status. Monitor. Control and protection command on highly available on fiber optic basis. Information is acquired once and distributed to all bus. The advantage of this digital substation: reliability and availability, safety and security, then lead time also reduce, footprint, then upgradability, maintenance, very less maintenance, flexibility. I just share this regarding the safety and security. As all the copper cable get replaced by this optic fiber cable, so there is a very less chances of accident and all that in switched area. This reduces the risk and increases the safety. This is the another SLD regarding the digital substations. This all are the conventional equipment. Then this is a process bus. After that process bus, get the data on common bus, and from common bus we can monitor and all that through our utility center. This is actually the main things in digital substation. Process interference box, which is installed near to our conventional equipment in switchyard, called as a PIB in short form. Process interference box placed yard near to a conventional equipment. In PIB, all yard equipment like transformer, ICT, CTPT, CB, isolator, etc., and wiring with copper cable connected as per conventional. And PIB, SAM input output unit, metering unit, MFM, and TCS relay are connected. It's communication between yard equipment to control room with control room ID and SCADA through fiber optic cable. In PIB SAM unit, the detail about the SAM unit is as follows. SAM 600 process bus input output system, standard metering unit. Bridging the gap between analog and digital technologies, SAM modular process bus input output system is placed in the field to connect conventional equipment to IC 61850 process bus. High accuracy for revenue metering while covering the whole damping range of protection. Fast data acquisition and communication for time critical protection application. Module for various process. Current measurement, voltage measurement, time synchronization, and scalable input-output binary signal. This SAM unit is important in digital substation. Switchgear control unit. Main use case. Interface input-output signal from primary apparatus for the use in bay and station level. Less cost to the primary in switchyard in order to optimize the copper cable and communicate via IC, same protocol. This is our relay panel, regular relay panel in control room. Process bus is connected in between SAM input output unit and IDs or relay panel through fiber optic cable only. Station bus is connected in between ID or relay panel and SCADA system through fiber optic. It's transfer data from both sides. All measuring and control signals are transferred and communicated through fiber optic cable. Relay used for all types of protection and measuring as a conventional substations. This is actually conventional type relay wiring. It requires a lot of wiring from CT, PT, transformer internal side, WTI, OTI, with complicated wiring, difficult for connection and difficult to resolve the problem. Also difficult to replace the relay. However, in case of digital substation, just a 2 to 3 fiber optic wire come from switchyard and easy to wiring connection. Also very easy to find or rectify the issue in operation. Substation automation also get benefit from the digital fiber optic cable. Substation monitoring and control, data management, cyber security management, primary equipment monitoring, secondary equipment management, and providing data to higher level asset healthy system with easy. Our that 220 kV Kekatimbora substation use SCADA, ABB, SCADA, all that means the processing unit also from ABB. All the substation designed and commissioned by ABB. SAS panel is connected between, all that thing in previous slides. This is our actual SLD in that 220 kV Kekatimbora substation, 220 kV level. Having two number of ICT, 220 by 132 kV. $100 MA number one and 100 MA second one, along with 132 kV feeders, and the same substation having 132 by 33 kV level with two numbers of power transformer, 50 MA. This one and also this one, and including all the spare bay and regular bay, total 8 numbers of 33 bay outgoing feeders from Kekatimbora substation. Substation bay details: 220 kV level 10 numbers of bay, then 132 kV level 8 numbers of, and 33 kV side total 17 numbers, including PT bays, station transformer, capacitor banks, spare bay. This is the detail of the equipment. ICT Toshiba make, transformer also Toshiba make, station transformer detail, their capacity, current level, also impedance as per tap is given. Thank you. I also share one on related photos, current photo of stations. Screen is visible to all. This is the current
Yes,
photo of, this is the current photo of 220 kV Kekat Nimbora substation. This is our ID panel. Processing interface unit for 100 mA transformer at switchyard near to that our convention unit. These are the processing interface unit near to our convention substation in switchyard. This is for CTs and all that. Internal view of processing interface unit. This one. Only the conventional wiring used to from our switchyard equipment to this unit only, and from that you use the fiber optic cable to our control room. And these all are the SCADA base utility center. Our control and relay panel based on the IC protocol. This is our conventional way of cabling. All are able to see? This is very difficult whenever there is issue of DC leakage or anything happen. This is completely replaced with the help of digital substations. ABB during that commission process make a one single small video. I will show the same. व्हिडिओ स्क्रीन सगळ्यांना दिसते?
नाही सर
नाही
व्हिडिओ
सर.
स्क्रीन नाही दिसत.
व्हिडिओ स्क्रीन नाही दिसत आहे.
एक मिनिट. This is all about the digital substation in MSTCell. MSTCell also use various modern technologies and also implement the same during maintenance as well as the commissioning of the various substation. For diagnostics purpose, our level we use the thermographical image. Just a very handy camera. This one, all can see. This is the thermal vision camera. Our technical staff, means artisan, all that easily use this one, and they all familiar about this camera. Flare make thermovision sensing camera. This camera very useful pre-diagnostic the equipment by thermal scanning. Our staff every bi-monthly carry out this thermo scanning to each and every joint, clamp connectors as well as equipment. Just a simple way. From ground level, in online, all equipment is in a running condition. Just our 2 person by using this camera take all the joints picture, thermal picture, okay, and from that we know where is the hot spot is created, and during outage minimize the same, so that it avoid the breakdown and all that. I just share the photographs image in that camera. Okay, this is the images of camera. thermovision camera before the temperature at jump, burst jump. It was 83.1 degree. The real image after attending the same temperature get reduced and avoid the occurrence of jump, cut and all that. Next. This shows the high temperature in city jump 107 degree. The real image city. This city is belong to the B phase 33 के उपनगर feeder. So another city. Before temperature, after temperature. You use this camera bi-monthly in your routine diagnostic testing. Another hotspot generated 82.2 degree. Actual, we all consider above 60 degree temperature are hotspot and below 60 degree all are the normal temperature. Only attain 60 degree and above hotspot. And the actual time of taking this images is peak load period. As peak load period, you all know the load increase and hotspot chances of hotspot generation is more. Means various maintenance practices, MSTC will use latest technique like thermovision scanning, then also use drone or monkey patrolling in hilly areas to avoid the tripping time and reduce the
6827435554.
I just go through the MSTCL at a glance. The MSTCL is the largest electrical power utility in state sector, having 742 EHV substation, 51,518 circuit transmission kilometer, having 1,38,598 MVA transfer capabilities, also 12,784 MVA reactive power consumption, and the infrastructure plan for 5 years is about 23,692 crores and having capability for handling 21,000 MW of power megawatt, transmitted 1,91,536 MUs in financial year 2023 and 24. Staff strength around 15,000. Our 742 substation detail as per voltage level. This is one of the STO having 765 kV substation. Also, MSTCL is one of the entity having HVDC, its own HVDC. HVDC line along with 2 number of substation at Padga as well as Chandrapur. However, in other S2 HVDC totally handled by PGCIL. Or 433 numbers of 400 kV substation, 254 our own 220 kV substation, 365 numbers 130 kV substation, 41 numbers 110 kV, then 39 numbers of 100 kV substation, and 7 number of 66 kV substation. Some modern initiative taken by MSTCL ERP system. First transmission utility in India to implement ERP, that is called as SAP solution, including it is very difficult to implement SAP in a such organization because in MSTCL various substation, storage location and plant. However, SAP is implemented successfully in manufacturing sector where in a one corridor all the operation is done. However, MSTCL distributed all over Maharashtra and it is very difficult to implement SAP at that time. But nowadays, our all employees are familiar with the SAP and easily handling all activities. Our inventory, then diagnostic results are operated through SAP. From a single click, we can know the detail about the diagnostic of the transformer or any equipment through SAP system. So no need to circulate hard copies of data. It is very easy for communication and controlling monitoring purpose. We also start fiber optic communication through our transmission line and nearly about 2,801 kilometer already done and other is in progress. This will help and generate a new side of business in MSTCL as it just replace our conventional earth wire by fiber optic cable. Means that cable used for two purpose in MSTCL. One for earth wire and another is communication purpose. Also, we explore these two outsider on lease basis. Smart grid pilot, WIMS and IT initiative. 765 kV substation first by an STU. No other state transmission utility having the 65 kV substation. ABT metering system and online view of ABT metering data. Or all data from 132 kV as well as 33 kV and as above are directly live view to the SLDC center Kalwa by using this ABT metering system. We also implement most of the substation SCADA, RTU-DC and for direct monitoring from SLDC Kalwa. Substation monitoring system is one of the part of SCADA system and we have 26 location with normal working of SAS system. 9 location having video conference facility in MSTCL. We also commission unmanned remotely controlled substation at Rajur in Nasik area, Chandwad, Taloja. We also have JS substation 400 kV Hinjawadi Pune, 220 kV Bhandup Mumbai, 220 Khandwa Pune and 130 kV Rastapet Pune. Also recently in last week our management sanctioned the MBR for 400 kV JS in Nasik area near to Nipad Taluka. Location is Sarola. It is very easy onwards. So we can visit JS substation in our nearby area, that is in Nipad area. And their completion date is within 2 years. We also having 7 numbers of RTC training center in Maharashtra or enhance the skill of our employee in-house. Okay, I conclude my presentation. Anybody has query can raise.
please ask question.
This is opportunity to show you that thermovision gun or that called as thermovision camera. Very easy. We also have drone for each subdivision, line maintenance subdivision. Nasik having more than 8 subdivision and 8 line maintenance subdivision, and each subdivision having the drone camera for easy and fast restoration of the line tripping and get fault location easily instead of the using manpower. This is just like the video camera in, okay, all can see. Thermal scanning image.
If participants have any doubt or any question, please feel free to ask or discuss with our speaker.
हा सर बोला ना.
हां, हां. नमस्कार. हां, थर्मल इमेज प्रोसेसिंग किंवा आपण कॅमेऱ्याचा यूज फक्त हॉटस्पॉट डिटेक्शनसाठीच होतो का? म्हणजे एखाद्या पर्टिक्युलर कंडक्टरमध्ये किती हे होईल किंवा
Yes.
ट्रान्सफॉर्मरमध्ये तिथंच त्याचा फक्त यूज आहे का?
Yes, sir. Yes, sir. Because, sir, what happened?
हं.
जस्ट आपल्या बॉडीचं बघा ना, जेव्हा आपल्याला काहीतरी बरं म्हणजे म्हणतो ना आपण बरं वाटत नाही तर बॉडीचं टेम्परेचर वाढतं. इट्स अ इंडिकेशन साईन.
ओके.
टेम्परेचर इन्क्रीज इज द इंडिकेशन साईन ऑफ आपल्याला काहीतरी म्हणजे काहीतरी आपल्यामध्ये म्हणजे म्हणतो ना आजारी पडतो आपण. इन इक्विपमेंट whenever there is some disturbance in inside the equipment, sparking or anything PD, measure of the partial discharge occur in power transformer during operation. Okay.
ओके.
This camera take 3 pictures top for transformer, top side, middle side and bottom side. Okay.
ओके.
Temperature. If there is a PD occurs now, then automatically that temperature get increased that part and capture in the camera. So we can easily before means pre maintenance activity actually
Okay.
as well.
ओके. ओके.
And this reduce the permanent failure of the equipment.
ओके. थँक यू सर.
And very easy handling.
And I think in the Nasik city, SCADA system is implemented to every substation, na? Means
Not every, but all the new substation is commissioned along with SCADA only now.
Okay.
It's on. But old substation is also
Huh.
use conventional techniques only.
Okay. And means is there any upgradations regarding the transmission sector, considering the smart city Nasik point of view in the electricity sector?
Yes, sir. Actually, Discom set up 2 to 3 33 kV substation to handle the extra load of that Kumbh Mela and all that. And for that purpose, we also provided 33 kV feeders and through underground cable 33 kV levels. Okay, and our Adgaon power also get augmented with 50 MVA 130 by 30 kV power transformer to
Great.
cater that power demand. Adgaon as well as Masroor, this Dwarka Takri also, and that Amber side for Trambak. Also add new 33 kV feeders so that alternate arrangement can be provided at DISCOM end, MSDC lane to
Okay.
each and every 32 kV substations.
No. Thank you, sir.
Okay, sir.
Sir, now GI substation working or not?
Yes, sir. All our GIS
Sir,
substation is in working.
वर्किंग कंडीशन ओके.
हाँ,
जो निफाड़ में अभी चालू होने वाला है वो जो अभी तक चालू नहीं किया है ना, अंडर
नहीं,
मेंटेनेंस है ना?
just MBR sanction and work allotted to Steel Make India.
ओके सर.
हाँ, तो just primarily civil work is in process.
ओके. हाउ मच केवी सर?
400 kV, 422 kV.
ओके सर.
आणि आपल्यासाठी खूप चांगली गोष्ट आहे की इझिली वी कॅन विजिट दॅट GIS
विजिट दैट.
Yeah.
यस सर, यस सर. Okay, I will contact you definitely.
Yes. 2026 तक कमीशन हो जाएगा 400 kV GIS एट सारोळा विलेज नियर टू निफाड.
निफाड़.
Yes, that PGCL 400 kV छत्रपती संभाजीनगर टू बोईसर लाईन ला टॅप करणार आहे आपण तिथं आणि 400 kV सबस्टेशन तिथे आपण बनवणार.
ओके सर.
हा, आपल्याला जेव्हा तुम्ही पिंपळगावच्या पुढे जाताना ती 400 kV छत्रपती संभाजीनगर टू बोईसर लाईन दिसते ना, त्या सेम लाईनला आपण टॅप करणार. टॅप म्हणजे इलेक्ट्रिक याच्यात आम्ही टॅप म्हणतो, ती लाईन आपण तिथे खाली त्या सोर्स सप्लाय आपण तिथे घेणार.
सर, GIS सबस्टेशन हँडल करताना आणि आपल्याला नॉर्मल सबस्टेशन हँडल करताना म्हणजे काही त्याच्यात डिफरन्स असतो का, की काही असं वेगळं प्रोटेक्शन घ्यावं लागतं?
नाही सर, प्रोटेक्शन ऑल सगळं सेम आहे.
ओके.
एवढंच आहे का आपल्याला जागा कमी लागते. GIS कन्सेप्ट इज ओनली टू रिड्यूस द लँड रिक्वायरमेंट. 400 kV सबस्टेशन करायचं ठरलं तर आपलं जनरल जे आहे नाशिक झोन मध्ये महाबळेश्वर सर्वात नियरेस्ट 90 किलोमीटर फ्रॉम दिस नियर टू शिर्डी, त्याला
शिर्डी,
70 महाबळेश्वर 400 kV त्याला 75 एकर जागा लागली आम्हाला, म्हणजे ते 400 kV बनवायला. हा, तर 75 एकर आणि आपल्याकडे जी थोडी नॉर्मल लोड शेडिंग किंवा काही लोडचा इश्यू येतो तर ड्यू टू ओनली का आपल्या नाशिक सिटीमध्ये 400 kV सबस्टेशन नसल्यामुळे, आणि 400 kV जर कन्व्हेन्शनल बनवायचं ठरलं तर 75 एकर जागा कुठे मिळणार.
हो, तो मोठा विषय आहे.
हा, तर मग त्या याच्याने आवर मॅनेजमेंट टेक डिसिजन का आपण GIS करू, आणि मग ते GIS सारोळा जे गाव आहे तिथे आम्हाला म्हणजे गव्हर्नमेंटने लँड पण अलॉट केली. तसं MBR पण झाला, ऑर्डर पण प्लेस झालेली आहे, आणि मग ते GISचं काम आता सिव्हिल वर्क इज इन प्रोग्रेस आहे. तर सिव्हिल वर्क पण होईल आणि मग तिथे ते GIS सबस्टेशन बनेल. तर मेन इश्यू ते लँड कन्स्टंट असेल तर तिथे आपण GIS प्रेफर करतो. पुण्यात पण बघा तुम्ही, पुण्यात पण आपले जे सबस्टेशन झाले ते सर्व IT पार्क वगैरे, आणि रास्तापेठ म्हणजे एकदम सेंटर ऑफ द सिटी. पुण्याची जी सेंटर ऑफ सिटी आहे ना, तिथे आपलं झोन ऑफिस आहे स्वतः, तिथे झोन ऑफिसच्या पाठीमागे जस्ट एक छोट्या याच्यात ते GIS बनलंय, आणि तिथून टोटली आणि त्याला जी केबल यूज केली, आता तुम्ही विचारलं GIS तर केलं तुम्ही सेंटर ऑफ द पुण्यात, मग त्याला हे कुठून आणले, काय त्याला लाईन, ट्रान्समिशन लाईन. तर आपण तिथे अंडरग्राउंड केबल 132 kV ची अंडरग्राउंड केबल यूज केलेली. त्याच्यानंतर भांडुपला 220 kV सबस्टेशन केलंय आपण GIS, त्याला पण 220 kV ची अंडरग्राउंड केबल यूज केलेली. म्हणजे MST will also get modernized along with the public and all that.
ओके, थँक्यू सर.
आणि ते सेमच असतं, फक्त त्याच्यात काय असतं, तुम्ही जे विचारलं मेंटेनन्स वगैरे, तर एका क्लोज चेंबर मध्ये टोटल ती असेंब्ली असते, सर्किट ब्रेकर तुमचं ऑल CT-PT, त्याचं ते मॉनिटरिंग असतं, लिकेज वगैरे, लिकेज GIS म्हणजे गॅस लिकेज डिटेक्टर वगैरे येतं, ते त्यांचं मेंटेनन्स असतं इयरली, तो आपण करत असतो.
Participants have any other questions?
चल मॅम सगळ्यांचे आय थिंक डाऊट क्लिअर झाले ना.
ओके. कन्क्लूड करायचं सर मग.
येस सर. येस मॅम.
Okay, okay. Thank you so much, sir, for this enlightening session. I'm sure all of us have gained the valuable insights into the topic modernization in electrical power sector. The topics you have covered, that is digital substation and all. So, and we also appreciate your work you have done as a member of MSCTCL. So, congratulations on that, sir.
थँक्यू
Let
मॅम.
us now take Yes, sir. Let us now take the lunch break before we continue with the next session. We will reconnect at 2 p.m. That is, okay, 2 p.m. Till then, please enjoy your lunch. And meanwhile, please fill the feedback form, which is shared on the WhatsApp group. Thank you. Thank you, everyone.
थँक्यू मॅम अँड थँक्यू
Thank you
ऑल.
so much, sir.